section 2.4 on biconditionals and definitions. Okay? As we're getting into this, we need to know what a biconditional is. Well, a biconditional, I underlined the BI because it means two. There's two conditions. It's two statements in one. What are the two statements? Well, let's look first at how we write a biconditional. Here's the symbolic notation. It's a double-headed arrow. P, arrow, double-headed, Q. Here's what we say. P, if and only if Q. So the two conditions are the conditional okay, so the conditional is one of those statements, one of the conditions. The other condition of the two conditions, remember, is Q to P, or if Q then P. Now, let's see how this works. If this is if P, then Q, Q to P means if Q, then P. What is supposed to happen here? Look at what happened here. We have the conditional. This should look familiar because this is called the converse. The two conditions. 1, the conditional. 2, the converse. Those are our two conditions in our biconditional. So, what do we have here? It says write the conditional statements and converse within each biconditional. So, here I go. The conditional. I'm going to underline everything but this, because this really isn't important. Now that we know it's a biconditional, remember, we've talked about this in class. So this is going to be P, this is going to be Q. So when I write the conditional, I write if two angles, I'm using shorthand, that's a good note for you. If two angles are congruent, then their measures are equal. Okay? If two angles are congruent, their measures are equal. So that means the converse would be if Q, then P. So if their measures are equal, then two angles are congruent. See how that worked? So those are the two statements. See if you can do this next one on your own. I'm going to go ahead and go through it. You can pause it and write it. Conditional would be part A. Remember, we don't need that now. And part P and Q. So the conditional looks like this. If a solution is a base, then its pH is greater than 7. The converse looks like this. Q to P. If pH is greater than 7, then a solution is a base. Okay, so this is a simple switching mechanism. We just switch these things back and forth. So you're kind of seeing how this works. In example 2, what we're doing is for each conditional, write the converse and a biconditional. So very first, before I do anything, here's what I'm going to do. I'm going to underline my necessary information. Okay? I'm going to label them P and Q and go from there, because my conditional is going to be if P then Q. So that's going to be, oh, we're just writing the converse. We already have the conditional. My mistake. So we are just writing the converse. We already have the conditional. You should have told me sooner. Converse looks like this. It's going to be if Q, then P, and it's going to say this. If it divides the segment into two congruent segments, then it's a midpoint. Okay? So how do I write this biconditional? Here's what it's going to look like. It's going to be P, double-headed arrow, Q, or, let me make that look more like a Q, P, if and only if Q. Okay? So let's write it. A point is a midpoint if and only if it divides the segment into two congruent segments. Okay? So a point is a midpoint if and only if. Here's my key. Guys, here's my key right here. It's got to have the if and only if. This is a true biconditional. Okay? See what you can do with the next one. I'm going to go ahead and roll straight through it. So, crossing out my unnecessary information, underlining pertinent information, labeling P and Q, and I'm going to write the converse. If x equals 3, then 2x plus 5 is equal to 11. And here's my biconditional. It's, remember, P, double-headed arrow, Q, and it is 2x plus 5 equals 11. If and only if x equals 3. You see how this is working now, okay? And so when we go on to this next example, we're going to be analyzing truth. Here is our key. To be true, both conditions must be true. Okay? To be true, both conditions must be true. So we need to break it into its two components. So here we go, guys. Conditional. I'm going to go here. I'm going to underline because I'm a student that really needs that reinforcement, really needs to know what's going on. So what I'm going to do is I'm going to label P and Q, and now we're going. If a square has a side length 5, then it has an area of 25. Now, let's do this. Is this true or false? If a square has a side length 5, then it has an area of 25. That's true. So we're going to move on to the converse. if Q, then P. So if it has an area of 25, then it has side length 5. Is this true or is this false? Okay, so this is obviously true. So because both of these are true, A is true. The first one is true. So, okay, so two trues make another one true. Go ahead and see if you can do the next one. I'm going to roll on through. So if the number n is positive, then 2n is a natural number. And the converse would be if 2n is a natural number, then n is positive. Well, let's analyze the truth behind this. If the number n is positive, then 2n is a natural number. This is true. Natural numbers are counting numbers like 1, 2, 3, 4, 5, 6. But if 2n is a natural number, then n is a positive number. What if n was 1/2? Then 2n is equal to 1, which is a natural number. But n would not be a natural number. Okay, so this should actually be this is correct. So 2n would be 1. N is a positive integer. That's not true. Because 1/2 is not an integer. So if 2n is 1, then n would be equal to 1/2, which is not an integer. So this is false. So we are false down on this one. Okay, that's analyzing the truth value of a biconditional. Okay, so as far as definitions are concerned, definitions are written as if and only if. Okay, and for your reference, if and only if can be written capital I, capital F, capital F. Okay, so look at the definition of a polygon is a closed plane figure formed by 3 or more line segments. Each segment intersects exactly 2 other segments only at their endpoints, and no 2 segments with a common endpoint are collinear. So here we go. A 3-sided polygon is a triangle. A figure is a triangle if and only if it has 3 sides. Okay, so that's how this if and only if. It may be implied. Okay, so it may be implied, the if and only if. But let's see if we can do one of these, and one will leave open for the end. I'm going to do this one down here. I'm going to do B. Okay, so a quadrilateral is a 4-sided polygon. Let's write a definition as a biconditional. So a quadrilateral is a 4-sided polygon. Let me rephrase. A figure is a quadrilateral if and only if, and I'm abbreviating there, that's good for us, if and only if it is a 4-sided polygon. Okay, guys, that's all I got for today. We'll discuss A in class, but if you've got the basic gist of the biconditional as 2 conditions, you should be good to go. We'll see you next time.